per meter square. There will be other possible units in addition to Pascal, which probably you heard more of than Pascal itself. So when you listen to the Weather Channel or whatever, they talk about millibar. In chemistry, sometimes you use ATM. So 1 ATM is equivalent to 1.013 times 10 to the 5th Pascal, or which is the same, 101.3 kilopascal. Sometimes we will use also the term bar or millibar. So when you hear the Weather Channel, they talk about millibars, the amount of millibars in a hurricane, whatever. So 1 bar is approximately 1 times 10 to the 5th Pascal. So in other words, 1 bar is approximately 1 ATM. It's just to approximate, instead of saying 1.013 or whatever, which is very tedious. It's better to say bar because this is 10 to the 5th Pascal. So in this class, you can use interchangeable atmosphere as 10 to the 5th Pascal rather than this number. Doesn't matter, it won't change too much the answer. Good. Or, which is the same, 100 kilopascal. Sorry, yeah. Okay, this is what we call pressure. Now, the pressure, as you know, and this is one of the basic statements of the Pascal principle. First of all, when we have a container with a fluid, at any point, the pressure will be the same from all directions. So it's the same pressure from this, or from here, or from here, or from here, or from here. It doesn't matter. At that point, the pressure will be the same. Additionally, if we have in the container an object, we know that the pressure at this point, if we compare the pressure at these 2 points, on which point the pressure will be higher? At the bottom. Everybody knows that from scuba diving or going to the beach or whatever, so you know that the pressure on the bottom is greater than the pressure on the top. Common sense. So, Pascal additionally said that if there is a pressure on a fluid, external, that pressure will be acting on every point in the fluid. So, if this is an external pressure and I want to find the pressure here, so the pressure here will be the pressure due to the depth at this point plus the external pressure. This is basically the Pascal principle. That on a fluid confined, an external pressure will act on every single point. In other words, Pascal principle said that the pressure, what we will call absolute pressure, will be the pressure at this point, which we will call gauge pressure, plus the external pressure. This will be called gauge pressure or pressure due to the depth. Of course, when the fluid is at rest. So, what will be that pressure due to the depth? Very simple. If we have the pressure here, imagine that we have a fluid here, a body of fluid. So, the pressure here due to this fluid will be, yes, I want to find the pressure due to the depth. The pressure due to the depth, which when the fluid is at rest will be called the gauge pressure, will be the pressure from the top of the fluid. Let's say, imagine that we have the fluid here. So there is a body of fluid here. So will be the mass of the fluid times gravity. So at this point will be the body of fluid. Imagine that this is a body of water. I am putting like a cylinder, but just to see that is the amount of water at this point on this surface. So what will be at this point the pressure? Will be the amount of fluid that we have here over this area, according to this equation. So will be the weight of the fluid divided by the area. But when we are talking about the fluid, we don't say it, or we don't state the mass. It's better to work with density. So the formula for density said that the mass is the density times the volume. So if I come to here and replace density times volume times G divided by the area. But we know that the volume is the area. If we have a cylinder, the volume will be the cross-sectional area of the base times the height. This is the volume of any object. The area times the height. Since we have the area times the height, replacing area times height times gravity divided by A cancels out, and we get that the gauge pressure is rho g h, where h is the altitude from the bottom or depth from the top, the way you want to call it. Altitude from the bottom or depth from the top. Either